Hey, welcome back, boys and girls, to my advanced programming concepts using C++ videos. This is lecture 2. So what we're going to talk about is get to the nitty-gritty of the code, right? So first lecture, I just explained kind of the concept, the fundamental concept, and now we're going to put it into practice, at least simple practice first, right? So on the right side, you see my Replit, which is the IDE that I use. It's an online compiler. Pretty good. You should join. I recommend it highly. And what I've done here is I've defined a simple function called displayMessage, and this has no parameters, and the return type is void, meaning it doesn't really return anything. The function itself is going to print out hell from function showMessage, right? I should change the name of this actually. And we can put it here as well. Okay. This is my function definition over here. And this is what we call a function call. So there are a couple of things that are going on here, right? You can have a function definition without a function call, but it really wouldn't do anything. The other thing I want you to notice is that the function is defined before the main, even though the main function is your initial point of entry. So the initial point of entry would be here. The definition of my show message function is before the main. Now, the reason that always has to be, it's a hard and fast rule, is because the compiler needs to know what the return type is and the parameters of the function before it actually is able to call it. In this example, we've not only included the return type and the parameters, which in this example there's no parameters, we've also included the function definition. Now, there is an alternative way to do this. This is not my favorite way to do this. I'm just showing you as a simple example, just so you don't get everything all at once. Not my favorite way to do this. There's another way where you can shorten this a bit, somewhat. Okay. Now, a couple things that are happening here. If you look to the left-hand side, I've defined as to where everything is. So you see that the function header, what we call the function header, is defined over here, right? That's what I'm highlighting. The function call itself is happening inside the main. So this is the function call. Okay. So what we can, if we want to visualize this, okay, let me move this a bit so you guys can kind of visualize. To visualize this a bit, you're always going to have the main on top, right? And then this has a procedure, or what we call a function, called showMessage. Okay, now let's get back to the code. In the code, what is happening here is when you start execution, it's going to go in here, it's going to print this out. So this would execute first. It comes into the function call. This executes second. When it goes into the function call, this is going to block, meaning it's actually going to step into. So we're going to call this step into. I'm going to write this here. Into this function called displayMessage, which means that now we're entering the displayMessage function and we're going to enter the body, which means that now we start executing whatever is in the body. So we think of this as the actual detail of step 2, right? So the execution step 2. Once this is done, once this is finished, then we continue here. That's 3, and then we continue here. This is 4. Okay? Remember, step 3 cannot happen until step 2 is finished. And how does step 2 finish? Well, it's got to go through the function body of displayMessage. And that's basically the way functions are stepped through in your program. always remember that first, always we go inside the main, and then any functions that you write and you call inside the main are going to be stepped into, and they must finish before the next line of code inside your main executes. Now you're probably asking, well, does this rule apply to function calls within a function, right? And that is exactly right. If you had a function call within display message, then display message would stop at that point, and then that would go to another function call. So what I mean is, let us say that we have another step, do something like that, right? See out. And I had another step. I'm gonna call here, right? Now you notice something weird here. It says used of undeclared identifier anotherStep. Why do you think that is? Why do you think that is? Why don't you pause the video and let me know? So the reason for that is, you ready? What concept did I just say about the main function and declarations of functions? It's got to know the data type and the parameters, right? Before it enters the main. Same rule applies to functions that are defined. Another step, the compiler, when it enters execution, right? Main knows about showMessage, right? But showMessage doesn't know about another step because it's after showMessage. So remember, the compiler does this sequentially, okay, in terms of compilation. So what we need to do to fix this is we can say, take this and put it up here. This is why I don't like defining the body of, well, defining it this way. I don't like defining it this way, but this can get a little messy as well. Okay, so again, now the showMessage function knows about another step because it comes before it. Okay, so always remember that, because I've gotten bitten in the butt about that. Now, let's take a look at this example here in terms of stepping through, right? If we step through this and we go into showMessage, right? We come into showMessage, comes in here, and then it stops here because it's got to go into another step, and now it goes over here, right? Which means that, again, the rule applies. We can't continue with showMessage until another step is finished, and then it continues on. So in this particular case, what we have here is the main is calling showMessage, and then showMessage is calling another step, right? And I can't come back from another step. I mean, I can't come back from showMessage to main because I gotta wait till another step is done. So this is what we call synchronous execution. So synchronous means synchronously we're executing each function in a synchronous manner, where we have to wait for one to finish before we continue. Okay. Okay. So this is again the lecture about writing and defining your function. I hope you are starting to pick up on certain things that you can do with your programs, and I'll see you on the next lecture.